Our next speaker is Wojciech Janisiewicz. I'm close, I think, and Wojciech has been working as a post-harvest pathologist at the USDA ARS Appalachian Fruit Research Center since 1984. His work has been focused on developing biological control of post-harvest decays of fruits using bacteria and yeast naturally occurring on the fruit surfaces. And today he's going to speak about progress, challenges, and future prospects in controlling fruit decays using biological control.
Thank you, Steve, and good afternoon. In preparing this talk, I realized that some of you in this audience, and particularly on the web, might not be familiar with post-harvest system that we are working with. So the first part will be just a very brief introduction to our post-harvest system that we are working with. Apples and pears are harvested in orchards to those large wooden or plastic bins. They are loaded on the trucks and they are brought to the packing houses. However, before they are put to storage, they are drenched with suspension of antioxidants like diphenylamine or etoxyquin that are used for controlling superficial scald, which is a physiological disorder. But fungicides are also added to the drenching suspension to protect against decays. An entire truck is passing through the drenching system, and the suspension is recirculated many times. So you can imagine that everything what is in the bins, fruit and soil carried underneath of the bins from the orchards are washed, and you create some kind of a soup. And if you take a sample from this drenching suspension and plate it on agar media, this is what you could see. Variety of fungal colonies like Penicillium expansum, Rhizopus here, some Alternaria, Botrytis. All of them can cause fruit decay. There are also many small colonies, yeast and bacteria, which are natural colonies of the fruit surfaces. Bob Spad, about 20 years ago, conducted epidemiological research in post-harvest, and he showed the relationship between concentration of fungal spores in the suspension and amount of decay on wounded Anjou and Bosc pears. So you don't need much. 100 spores per mil will cause 71 to 83% decay depending on the cultivar. Under commercial conditions, I mark this with arrow, this is the concentration of the spores that you will find. So obviously, some type of protection is needed to control those decays. And fungicides have been the major weapons to control decays in post-harvest, but we all know very well limitations to fungicides, and I'm not going to go in any special details here, but just to refresh your memory, sustainability is a big limitations. Resistance developed in pathogens is a big problem. There's greater and greater difficulties in developing new pesticides because there's harder to find a new chemistry. And of course, very well publicized effect of fungicides on the environment and human health, which increase social sensitivity to use of pesticides. Public simply demands reduction in use of pesticides in food. And a European survey in 2006 showed that 71% respondents in the European Union already worry about pesticides residue in fruit. Early on, since I started my project in 1984, we have several visits from different companies, but they were very interested to find some kind of alternatives to fungicides used on fruit. Gerber was one of them. Eventually, you can find right now various products, organic products from Gerber. When I go to organic fruit store and I was searching for different labels on organic products, and in case of apples, I found that actually the advertisement here is puts more emphasis on environment than on human health. But I think this probably will change with time, similarly what is occurring right now in Europe. Let me give you an example from our experience about 3 years ago. During winter months, we were running biocontrol experiments and with our fruit, we basically ran out of the fruit. So we went to the supermarket, we purchased some fruit, and we ran experiments, and nothing worked. Even controls inoculated with the pathogen alone did not develop any decay. So to make a long story short, we went again to the same supermarket, we purchased more fruit. Then we went to organic supermarket and purchased more fruit. We brought them to the laboratory, we cut them in half, exposed the flesh tissue, and spray with conidia of either Botrytis cinerea or Penicillium expansum. And this is what we saw. On organic fruit, the fungus grew all nice throughout the fruit, throughout the flesh tissue. However, on regular, from regular supermarket, which is conventionally grown fruit, the fungus didn't want to grow on the flesh, except around the seed cavity area. Similar situation was in case of Penicillium expansum. And this is in agreement with work of Zhao and Bold, who published in 2009 that residue of some of recently registered fungicides can penetrate as much as 3.5 centimeter deep, especially Peramethanol. Unlike in the past that you could get rid of the fungicide by washing the fruit or peeling, in this case you are really forced to consume fungicide with the fruit unless you buy organic fruit. I have to add it with all fairness that the pesticide residue level that Zhao published was within tolerance limits, and that those fungicides were registered under reduced risk fungicide list. So going to biological control, in 1984, Larry Pusey and Charlie Wilson, who at the time worked at our station in Kernersville, West Virginia, published this classic paper on biological control of brown rot of peach with soil isolated bacterium Bacillus subtilis strain B3. So when they wounded fruit and protected that fruit with B3 and then inoculated with pathogen, they obtained complete control. And on the right-hand side, there is our check, control treatments, wounded and only inoculated with the pathogen. This bacterium was never commercialized. However, Pusey and Wilson showed for first time conclusively that biocontrol could be effective under storage conditions which are much less fluctuating, and the target fruit is easily available to application of the antagonist. In 1984, I joined the station, and my work, I focused my work on developing biological control of two most important post-harvest pathogens, Penicillium expansum causing blue mold and Botrytis cinerea causing gray mold. And my work was focused on looking for antagonists among the natural microflora of fruit, yeast and bacteria that you normally consume with every fruit. You drink this with apple cider or apple juice. Developing biological control of post-harvest decays, and I will use this acronym throughout my presentation. It's a very lengthy process, so I don't have a time to go in any details here. The only things I would like to emphasize is that needs and opportunities must exist before you start a program like this. And in our case, the obvious needs for replacement or finding alternatives to synthetic fungicides existed, and Pusey and Wilson showed the opportunity in post-harvest system. We isolated many bacteria and yeast antagonists, quite effective. This is one of them, L5966, which was eventually commercialized under the name of BioSafe. You can see as you increase concentration of these antagonists, you can completely eliminate decay. And on the left-hand side, this is just a wounded fruit inoculated with the pathogen. So it took us about 10 years to put a commercial product on the market under the name of BioSafe, and actually EcoScience was the company which commercialized this product, the saprophytic strain of Pseudomonas syringae. Originally, the formulation was frozen pellet and was sold in those milk-like cartons and kept in the packing houses in wooden-like boxes with styrofoam and dry ice, and could be delivered on demand between 24 hours. Now we have a dry formulations of this product which are much easier to handle. This is the website of Postharvest Solution, which is currently owning the BioSafe and is marketing. You can find out more about it if you go to this website. It can be applied in a variety of ways. I need to say that originally it was registered for application to apple, pear, and citrus, although I never worked with citrus. They did some work with some other scientists in California. But it could be applied, like in this case, on packing line, could be applied during precise drenching, variety of ways. The registration was extended to cherries, and it could be applied in the flood boxes, and it's applied only in the years when there is a lot of rain around harvest and it's tendency to splitting and then infection by penicillium and botrytis. Barry Jacobson did some work in Montana and Ohio, in Idaho, on potatoes, and he found out that it was extremely effective against Fusarium dry rot and some other diseases. So registration was later on extended to application to seed potatoes, then later on to French fry potatoes, and then later on to chip potatoes. In case of potatoes, it's applied as this during piling up as a low volume spray. You don't want to put too much moisture in that situation. Holmes and Edmonds did some work with sweet potatoes against Rhizopus rot, and they showed that it was BioSafe was most effective among all other treatments. The top line represents the sound fruit, and the bottom line decayed. This is a control wounded and inoculated with the pathogens. All fruit or all potatoes were infected. And the IR4 program, they pursue registration for sweet potatoes. So currently, this is the recent pamphlet from Postharvest Solution indicating that it could be applied on potatoes, sweet potatoes, cherries, apples, and citrus, and variety of diseases. And that list is expanding. There's a poster, there's no anymore, poster was 19, which indicated how well it works on some new pear diseases in Washington state. It was by Chow and Bolen. So as we applied those biocontrol agents, this biocontrol agent, we found limitations. Some of them were quite predictable because it's a microbial antagonist, but some of them were kind of less predictable. It was affected quite, in many cases, by post-harvest practices, and the cost was a big problem for some growers. The BioSafe was developed for large orchard operations, like in Pacific Northwest, where you can change the drenching solution daily, maybe many times. And small orchard growers complained that it was too costly for them because they keep their small drenchers suspension for 3-4 days, and they have to recharge with the biocontrol agents every day because it does not survive that long in that suspension. So to address this, we developed portable drencher where you can exchange this tank, and you can manipulate the size of the tank based on the size of operation that you have, so you can change the suspension daily. And this is fully automated. You can go to our website and see how it works. It takes 5 minutes to drench 1 bin. So if you work hard, you can drench even as close, maybe close to 100 bins a day. So the other limitation I mentioned, that biocontrol is affected by a variety of different conditions. So you try to increase the safety margin just in the case when something happened, there's more mature fruit or something like that. And here we adapted this hurdle concept developed by Leissner in Germany against foodborne pathogens, that with which hurdle that you present, you reduce chances of contamination of food with foodborne pathogens. So we try to adapt this to our post-harvest treatment. And in the past, we and some other scientists developed a variety of other treatments that by themselves were not effective, but together they have an additive or even synergistic effect. And you can use those treatments. I listed them, all of them here, but you don't have to use all of them in the combination. But if you add, for example, calcium treatment, you can reduce amount of decay. We know that. Heat treatment, which is not used, but 38 degrees for 4 days can reduce decay. Treatment with sodium bicarbonate is used by the industry, can reduce decay significantly, but not totally. Antagonist, of course, is the strongest in reducing decay. Mixture of antagonists often are more effective than individual ones. Of course, low temperature reduce amount of decay. And then eventually you're coming to like control atmosphere, and then the pathogen cannot overcome that hurdle anymore, and you have a complete control of decay. So let me show you example from some of our laboratory experiments where we keep the fruit in CA. This is the control treatment, and CA or in air storage. You could see a lot of development of decay in CA, but in air storage, but in CA there is less decay. I mean, this is whole. The color of decay is different because you have a less oxygen, so it's less oxidation. But there's still a little bit of healthy tissue here. So there's just a slight difference. When you keep that fruit for a few hours at room temperature, it will turn brown like this one. So when we use combination of a few treatments here, two different antagonists, we call them F and S in this case, and we also use sodium bicarbonate and store that fruit in the air, still got some infections here. But when we use the same treatments but store fruit in CA, we get complete control. So this is a very good example of the last hurdle, which resulted in complete control, and CA by itself can reduce decay, but together with biocontrol agents and sodium bicarbonate, we can obtain complete control. So currently there are more than 24 programs worldwide working on biological control of post-harvest decays of various fruits, and all of this originated from work of my colleagues and in Kernersville in West Virginia. There are 8 products that were registered in different countries, mostly against apple and pear diseases, but also against citrus, vegetables, in one case avocado, and some other smaller crops. So we can ask ourselves questions: why there's so many programs, but there are only 8 products, and 7 of them are still on the market. And one of the reasons is the cost of registering biocontrol agent. You could see here a variety of different tests that must be conducted to register biocontrol agent, and this is very costly. In this case, in Europe, there's that qualified presumption of safety. There's a list of organisms which are benign, and if your antagonist falls in that list, you don't have to go through this extensive procedure. That list includes variety of organisms that you can find in yogurt, some fermented products that we already consume. And that list is updated every 6 months, I believe. And if that organism is not in that list, then it has to go to full assessment. And we need that list, some kind of a list like this in the United States to speed up registration, because there are a lot of good products there are many good antagonists that we could commercialize very easily. Just a couple minutes. The next frontier in biological control is developing biocontrol against wound decays originating from latent infections. The fruit looks sound and is not wounded when you harvest, but when it reaches maturity, it develops decay. It's very difficult to detect, actually impossible. And if you look on the sound fruit, What is happening, this is the conidia of the fungus on the fruit. This is under microscope. And it produced that apressoria. We call it lobate apressoria. They're a little bit different from other fungi. But they just stay there. And when the fruit matures, they penetrate the fruit and cause decay. So we thought that over time there was some interaction between organisms on the fruit surface, and there should be some evolution of antagonists against those structures. So we made massive isolation of microorganisms from fruit, nectarines and plums, and then we test them for colonization of those structures. And you can see here, this is Conidium apressorum, and this is just bacteria colonizing this apressoria exclusively. You can see right here, you can have a mycelium, it's not colonized, only apressoria. And when we apply this to a fruit under very controlled laboratory conditions, this is our check control, you could see as we increase concentration, and this is counterintuitive because the lower the number, the higher concentration is the turbidity, we can completely eliminate decay. And this is under controlled laboratory conditions. So the next step is to move this from laboratory conditions to the real world. And that's a big challenge for us. So if you looking some of that fruit that was protected, and you look under microscope on the skin, you could see that the fungus germinated, produced apressorum, and this bacterium colonizes that apressorum here and does not allow the fungus to penetrate and cause decay. Again, this is under very controlled laboratory conditions. So in conclusions, I would like to say that biocontrol has been established as a commercially acceptable method of control on fruit and vegetables. More research are needed in those various areas, and biocontrol can be justified on its own merits, but greater use of biocontrol could be achieved by expanding to new commodities, new applications, integrating with other alternatives, and streamline registration. And this is just something from growers. Thank you.